Hi class, this is the final video in the Pre-AP Solutions recap that I'm doing, the crash course in Solutions Chemistry. Talking about net ionic equations. Now a net ionic equation shows only the species that's actually involved in the reaction. So if there's something that's not really changing, we take it out. Okay. The steps in writing the net ionic equations are, first we need to write a complete balanced equation. It gives you the overall reaction stoichiometry, but not the forms of the reactants and products as they exist in the solution. It doesn't include the states of matter, breaking it apart into their ions, so we're not showing dissociation. Okay, so this is just simply, the complete balanced equation is just simply the way you learned to balance equations in the beginning of the chemical reactions unit. Then we're going to underline the solid precipitate to help us with the later steps. So we do have to pay attention to the state of matter because that becomes important later. Remember, we talked in the last video about how if it is insoluble, it's solid. If it's soluble, it's AQ, it's aqueous, it's dissolved. That's what I mean. We need to pay attention to the state of matter. Okay, so now the complete ionic equation. We are going to represent as ions all the reactants and products that are soluble and ionized in the solution. Okay, that's why we learned to break our to write the dissociation reaction. Okay, we're going to represent as ions all the reactants and products that are soluble and ionized in the solution. So remember to consult the solubility rules to do this. Aqueous, AQ, is soluble, so it will dissociate if it's ionic. S, solid, is what we put if it's insoluble, so it will not dissociate. It's not going to dissociate or split apart. So we got to write our complete balanced equation, then turn it into the complete ionic equation. Then we want to do the net ionic equation. Net means that we're going to take something out. We're going to take out anything that doesn't change. This includes only those solution components undergoing a change. It only involves the components, the ions that are involved in making the precipitate. So I'll go back over that in a minute. So we're going to cancel out all of the ions that are not part of the reaction process. They are called spectator ions. Got an example down here. We could write the net ionic equations for these. Okay, there's 4 examples. I'm going to try to do those with you. All right. Barium chloride. So barium chloride is Ba. Remember that barium has a positive 2 charge. Chlorine has a negative 1 charge. So this is BaCl2. If you need to do some pre-work over on the side just to let yourself know what it is, that's fine. Okay. BaCl2 plus silver nitrate. That's going to be Ag has a positive 1 charge and NO3 has a negative 1 charge. It's already neutral, so that's just going to be AgNO3. Yields. And then we want to predict our products. There's a switching that takes place. I have 2 compounds reacting. They're going to switch places. So I'm going to have the barium and the silver switching places. So I'm going to have silver bonding to chloride. Silver again has a positive 1 charge. Chloride has a negative 1 charge, so it's a 1-to-1 ratio. AgCl plus And then I'm going to have barium nitrate. Barium nitrate is Ba, has a positive 1 charge. NO3 has a negative 1 charge. I'm sorry, this has positive 2. Nitrate has negative 1. So positive 2, negative 1. I need 2 nitrates to balance out the positive 2 for barium. Okay, now I need to know what's soluble and what's not. Now, you're going to want to have your solubility rules handy so that you can go back and forth instead of just having to flip back and forth like this every time. You may want to print an extra copy of the solubility rules to help with this. Let me grab mine. All right, here, let's go ahead and just set this right here. And I'm going to be referring to these rules. First of all, we want to look at barium chloride. So I know that barium is in group 2. All right, there's chloride. Chloride is soluble unless it's combined with silver, lead, or mercury. Okay, this is aqueous. And by the way, you can pretty well assume that your reactants are going to be aqueous. Almost always, but let's just go through it. All right, nitrate is what I see. I don't see alkali metal, ammonium. I see nitrate. There are no exceptions. Nitrate is always going to be soluble. That makes it aqueous. Remember, soluble means aqueous. Soluble is aqueous. That seems counterintuitive. Nitrate is always aqueous, so I could say that's aqueous on this side, right? Well, that leaves silver chloride, so let's find it. Chlorine is soluble unless it's combined with silver, lead, or mercury. Well, this is silver chloride. It's insoluble because we had an exception. Insoluble, we're going to put solid. Okay, underline that. That's step 1. We just did step 1. We underlined our solid precipitate and we have written out the equation. We do want to go ahead and balance it. I have BaCl2. Okay, there's only 1 chlorine here. I'm going to put a 2 there. Okay. Over here I have 2 nitrates. Oh, that's not balanced. I'm going to put a 2 here. Now let's check everything. I have 1 barium, 2 chlorines on both sides. I have 2 silvers, and I have 2 nitrates, 2 nitrates. Now it's balanced. Okay, let's go to the second step. So step 2 is the complete ionic equation. This one can get a little messy, a little bit long. You know what, that pin is not a good color. It's kind of hard to see. Go in with this one. That's not any better. Oh well, it'll be fine. All right, everything that says AQ we're going to break apart into ions. So what would this be if it dissociated? If this dissolves, I have 1 barium, positive 2 charge, plus how many chlorines? 2 chlorines with a negative 1 charge. All right, I have 2 silvers, which has a plus 1 charge. I have 2 nitrates with a negative 1 charge. That yields, okay, 2, oh wait a second, this is the solid. Now here's the deal I want you guys to know. The reason we underlined this is because this has to stay together. It's solid. That's a solid relationship. It can't be broken. This relationship's not going to be broken up, okay? This one stays together. So we put 2 AgCl. That's solid. We're going to leave it alone, okay? And then my barium nitrate, I have Ba plus 2. And I have 2 nitrates. So 2 times NO3 minus 1. I have 2 nitrates, 2NO3 minus 1. Okay, then we get to do the fun part. This is the part where we get to cancel things out. So step 3 is come up with the net ionic equation. And I would go ahead and do half of the work up here and then just rewrite it. What we want to do in the third step is we want to cancel out our spectator ions. So anything that didn't change. In other words, anything that's not involved in making this. All right. Barium, it's barium plus 2 on both sides in step 2. It didn't really change. Okay, I have 2 chloride. Oh, that was part of making this solid, so I'm going to leave it alone. 2 silver. Well, that was part of making silver chloride, the solid. Okay, then I have 2 NO3 and 2 NO3. Getting rid of those. All right, and now we just want to write down the story. Okay, 2Cl minus plus 2Ag plus 1. And then we have 2AgCl. That's our net ionic equation. Net ionic equation is just the facts. It's just a straightforward story. We're going to leave out all the spectators that don't really get involved. Okay, so it is the formation of a solid relationship. You could think of it that way. We just want to tell the story of how this solid relationship was formed. There's a lot of other stuff that's going on, but it's not as important as this part. This is what really matters. It's the solid relationship forming. And anything that's not involved in the formation of that solid relationship, it's just side details and we don't need to know about that. Okay? So the net ionic equation gets rid of all the spectators that are not involved in forming the precipitate. Okay, let's do the next one. We're going to do a few examples because I think this takes some time to get used to. If you get to the point where you just get it and you're done and you can do any of these without any trouble, you can go ahead and stop at this point. But I'm going to do all of these so that you have the examples if you are not sure if it makes sense to you. Okay. All right. Let's look at number 2. Lead 2 acetate. Remember 2. That's positive 2. It's the positive charge. Acetate is a polyatomic ion with a negative 1 charge. The ion is C2H3O2 with a negative 1 charge. So that tells me I'm going to need 2 of these because it has a negative 1 charge and this has a positive 2 charge. So I have Pb with a positive 2 charge. Acetate is C2H3O2 with a negative 1 charge. Positive 2, negative 1. Okay, that's a subscript of 2. Hopefully that makes sense to you guys. All right, and I'm going to add that to potassium chloride. Potassium is a positive 1 metal. Chloride is Cl with a negative 1 charge. Okay, that's neutral. Okay. The next thing that we need to do is, well, let's finish it out first. We're going to switch. Ions are switching. Remember, lead is going to keep its positive 2 charge. So if lead gets with chlorine, then that's going to be PbCl2 because Cl has a negative 1 charge. Lead has a positive 2 charge. All right. Plus, and then over here, K gets with acetate. Potassium gets with acetate, so that's going to be K. C2H3O2, and because acetate has a negative 1 charge, potassium has a positive 1 charge, we're good. We're done there. All right. If we were to look at our solubility rules, which I have right here. All right. Acetate is right here. There's no exceptions. It's always soluble. So I'm going to put AQ. Chloride, Cl minus. It's always soluble unless it's combined with silver, lead, or mercury, so that makes this AQ. You'd also say, well, it's got a group 1 metal, so it's soluble. Group 1 metal and acetate, this is definitely aqueous. Now let's look at this one, PbCl2. Cl and Pb with +2 charge, oh, that's insoluble. That makes this our solid compound. Underline it. Okay, moving on to step 2. Want to break everything that's aqueous up. Only thing that stays together is the solid, so if it's aqueous, it breaks up. Pb has a +2 charge, and I've got 2 acetates. Each of them has a -1 charge. K has a +1 charge, and Cl has a -1 charge. All right, PbCl2, that's our solid. It stays together. PbCl2. And what we're going to focus on is what does it take to make PbCl2. And then we have K with a +1 charge. It's aqueous again. Plus C2H3O2 with a -1 charge. Okay, let's get rid of our spectators. Who's not involved in the actual formation of this relationship? Well, let's see. Pb is involved. C2H3O2. Do I have it on both sides? Oh, and I forgot to balance this, didn't I? Let me back up just a second. I forgot to balance it, and we need to make sure that we do that. Because I have 2 acetates on this side, I've got to have 2 over here. And I think that almost does it, because I also have 2 chlorides. I need to put a 2 here. Okay, 1 lead. I have 2 acetates. I have 2 potassiums now, and I also have 2 chlorines. Okay, we're balanced. I do want to carry those coefficients down, so I have 2K, 2Cl, 2K, 2C2H3O2. Okay, so sometimes if you forget to do the balancing, you can catch it right here and go back up and do it, but it saves you time if you do it up there. All right, now I want to cancel everything out. We said 2C2H3O2 with a -1 charge. I see that on both sides. I cancel it out. 2K plus 1, 2K plus 1. Cancel those out. But then I'm left with lead and chlorine forming lead chloride. So let's write that out. What would that look like? Pb plus 2 plus 2Cl minus 1 yields PbCl2. There's sample number 3. Or example number 2. Let's do number 3. Copper 2 bromide. Cu with +2 charge. Bromide has -1, so it's going to be CuBr2 plus aluminum sulfate. Al has a +3 charge. SO4 has a -1 charge, or -2 charge, so that's not balanced. I have +3, -2. It's going to be Al2SO4 3 yields. Well, we're going to have some switching. Copper goes over here, aluminum goes over there. So let's start by saying copper, it has a +2 charge, sulfate has a -2 charge, so it's just CuSO4 plus, and then aluminum and bromide, Al has a +3 charge, Br is -1, so it's going to be AlBr3. See if we can balance these. Okay, copper is good, bromine not so much. I need a 3 here and a 2 over here. Okay, that changes aluminum. So aluminum is good actually, but then I have SO4 I have 3 of them. Okay, let's put a 3 here. 3 copper. 3 times 2 is 6. 2 times 3 is 6. Bromide. Aluminum. 2 aluminum. I have 3 sulfate. 3 sulfate. We're balanced now. Okay, now let's look at our states of matter. CuBr2. Br is soluble unless it's with one of those 3. Copper is not one of them, so it's AQ. Al2SO4 sulfate. This is not an exception. It's not lead, mercury, strontium, or barium, so it's going to be soluble. So it's AQ, aqueous. Copper sulfate. Okay, sulfate, lead, mercury, strontium, barium. That one's aqueous. All right, and then aluminum bromide. Okay, bromide, except if it's combined with silver or lead or mercury. That one's aqueous. Okay, interesting. Now let's do the next step. So step 2, you have 3 copper with a positive 2 charge. And then I have 3 times 2 is 6, so 6 bromide, negative 1 charge. I have 2 aluminum, positive 3. I have 3 sulfate, negative 2. All right, I have 3 copper, positive 2. I have 3 sulfate with a negative 2. I have 2 aluminum with a positive 3. And I have 3 bromide with a negative 1 charge. Okay. So in step 3, I need to cancel out everything that was not involved in making a solid. Well, the deal is we don't have any solids, so I'm just going to cancel out everything. Copper goes away because I see it on both sides. 6 bromide. Oh, this should be 6. 2 times 3 is 6. I just did bad math there. All right, and then 2 aluminum. I have 3 sulfate. Well, good grief, I don't have anything. So this is actually no reaction. There's no reaction because all I have is just the same dissolved ions that I started with, okay? Because everything's still aqueous. So that's kind of a tricky one. Sodium sulfate, barium chloride. Na2SO4 plus BaCl2 yields NaCl plus BaSO4. All right, let's check. We want to have 2 of these. Okay, 2 sodium, 1 sulfate, got 1 barium, I've got 2 chlorides. Okay, let's check our solubility rules. Sodium, I already know, alkali metal, that's aqueous. Okay, barium chloride, it's a chloride, it's not one of those 3, so this is aqueous. NaCl is aqueous because it's an alkali metal. And then barium sulfate, let's see, SO4 and barium. That makes it insoluble, so it's solid. Underline that one. It's going to be our key in this problem. Number 2, we're going to break up everything that's not solid. So we have 2 Na plus. We have a sulfate, negative 2 charge. We have a barium with positive 2. We have 2 chlorides, negative 1. I have 2 sodium, positive 1 charge. And I have 2 chlorides, the negative 1 charge. And I have barium sulfate as a solid, and that one stays together as a solid relationship. Go to the third step, final step. We want to cancel out all of our spectators. I have 2 sodiums on both sides. Sulfate, that's part of it. Barium is part of it. I have 2 chlorides on both sides. So I'm going to say SO4 with a negative 2 charge plus Ba positive 2 charge yields BaSO4 solid, and that is it. I hope this was helpful. Hope it made sense. Let me know if you have questions. And that's it for our crash course in solutions from pre-AP chemistry.